Organic chemistry is the study of carbon-containing compounds. The field of organic chemistry is very important for a wide variety of reasons. A huge number of carbon-containing compounds are known. Most of the advantages in the pharmaceutical industry are based on the knowledge of organic chemistry, and life as we know it is based on organic chemistry. Most organic compounds have a skeleton that is composed of C and C bonds. The C and C bonds may be single bonds, which is called alkanes, double bonds, which is called alkenes, and the triple bonds, which is called as alkynes. Always remember that carbon forms a total of only 4 bonds. The skeleton of an organic compound that has H attached to it. H, these are hydrogens. Other heteroatoms like oxygen, halogens. So halogens, example of halogens, we have bromo or bromine, chloro or chlorine, fluoro for fluorine, and iodo for iodine. Nitrogen, sulfur, phosphorus may be present as well. And we have here some common or some familiar organic compounds. We have methane, propane, acetylene, and acetone. We have acetic acid, ether, ethyl alcohol, and aspirin. As you can see, the simplest compound or the simplest alkene compound is a methane. It composed only of one carbon, and there are 4 carbons, hydrogens attached to it. As you can see, the simplest alkane structure or alkene compound is a methane. It is composed of only one carbon, and there are 4 hydrogens attached to it or bonded to it. Then we have also propane, 3 carbons. Then this structure has a triple bond. Okay? And it is named as acetylene and acetone to indicate that this structure has a functional group or it is a functional group of ketones. Throughout our discussions in organic chemistry, you will know more of these functional groups. Okay? Acetic acid. Okay? We have COOH. Then ether. And OH indicate that this structure has alcohol. Organic compounds are commonly classified and named based on the type of the functional group present. When we say functional group, an atom or group of atoms that influences the way the molecule functions, reacts, or behaves. The center of reactivity in an organic compound. Some of the simplest alkanes. CH4, that is methane. CH3CH3 ethane. CH3CH2CH3 propane. CH3CH2CH2CH3 that is butane. And CH3CH2CH2CH2CH3 that is pentane. 1 carbon, 2 carbon, 3 carbons, 4 carbons, 5 carbons. When there are 6 carbon, it is called hexane. 7 carbon, heptane. 8 carbon, that is octane. 9 carbons, that is nonane, and when there are 10 carbons, that is decane. The previous alkanes are also called the straight chain hydrocarbons. When we say straight chain hydrocarbons, all of the carbons atoms are joined in a continuous chain. Alkanes containing 4 or more hydrocarbons can also form branch chain hydrocarbons, or simply as branch hydrocarbons. So some of the carbon atoms form a branch or side chain of the main chain. Okay. So an example here we have pentane. The three structure shown previously for C5H12 are structural isomers. When we say structural isomers, compounds with the same molecular formula but they have different bonding arrangements. Structural isomers generally have different properties. They have different melting points, different boiling points, and often different chemical reactivity. Organic compounds can be named either using the common names or based on the EUPAC, or that is International Union of Pure and Applied Chemistry, or the EUPAC naming system. So in naming alkane or the alkane nomenclature, first you have to find the longest continuous chain of carbon atoms and use the name of the side chain for the base name of the compound. The longest chain may not always be written in a straight line. Next, number the carbon atoms in the longest chain beginning with the end of the main chain closest to a substituent. Groups attached to the main chain that have taken the place of a hydrogen atom on the main chain. Name and give the location of each substituent group. A substituent group that is formed by removing an hydrogen atom from an alkyne is called an alkyl group. Name alkyl groups by dropping the ane ending of the parent alkane and adding YL. We have common alkyl groups or substituents. When it is CH3, that is methyl. When it is CH3, CH2, ethyl. CH3, CH2, CH2, that is propyl. When it is CH3, CH2, 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 that is butyl. Halogen atoms are another common class of substituents. Okay, name halogen substituents as halo. Okay, we have Cl chloro, Br bromo, I iodo, and F4 fluoro. When two or more substituents are present, list them in an alphabetical order. So take note that butyl comes first before ethyl, before methyl, and before propyl. When more than one of the same substituent is present, so you're going to indicate these following prefixes. But in naming this one, or when you're going to arrange in an alphabetical order, you're going not to ignore these prefixes. Okay? Di is 2, tri for 3, tetra for 4, and penta for 5. Okay. So name the following compounds. Okay. So the longest chain here is this one. Okay? Okay. In this structure, you may begin it left to the right, and you may also begin it on the right to the left. Since the methyl is attached on the fifth, on the third carbon, okay, it is on the exact middle, okay. So you may either begin it right, right or left. And this structure is a 3-methyl peptane. Okay? This is a 3-methyl peptane. Okay? For this structure, the longest possible chain, let us try to find out. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. But take note, you're going to name it on where the substituents is on the nearest end. Okay? You must also be able to write the structure of an alkane when given the IUPAC name. To do so, first, you have to take note of this following. You must also be able to write the structure of an alkane when given the IUPAC name. To do so, you have to identify the main chain and draw the carbons in it. Identify the substituents, type and the number, and attach them to the appropriate carbon atoms on the main chain. Add hydrogen atoms to the carbons to make a total of 4 bonds to each carbon. Okay, for this one, in your worksheet, I want you to draw the condensed structure of the following compounds. We have 3,3-dimethyl-pentane. We have 3-ethyl-2-methyl-hexane. We have 2-methyl-4-propyl-octane. And we have 1,2-dichloro-3-methyl-heptane. Alkanes. These are unsaturated hydrocarbons that contain a C and C double bond. Sa alkene nomenclature, names of alkenes are based on the longest continuous chains of carbon atoms that contains the double bond. So in naming an alkene structure or name an organic structure, you have to note whether there is a double bond or triple bond. And always include the double bond or the triple bond on the main chain. Okay? Find the longest continuous carbon chain containing the double bond. And you're going to change the A and E ending from the corresponding alkane to E and E. So butane, it will become butene, propane to propene, and octane to octene. Indicate the location of the double bond using a prefix number. Designate the carbon atom that is part of the double bond and nearest to the end of the chain. Name all other substituents in a manner similar to the alkanes, and use a prefix to indicate the geometric isomer present if necessary. Different geometric isomers are also possible for many alkenes. When we say geometric isomers, these are compounds that have the same molecular formula but and the same groups bonded to each other, but they have different spatial arrangements of the groups. Again, geometric isomers, they have the same molecular formula and same groups bonded to each other, but they have different spatial arrangements. We have two geometric isomers. We have cis isomer and we have also trans isomer. When we say two cis isomer, these are two identical groups on adjacent carbons on the same side of the CNC double bond. When it is a trans isomer, two identical groups on adjacent carbons on opposite sides of the CNC double bond. On your worksheet, I want you to draw the structures of the following compounds. 2-chloro-3-methyl-2-butene. Alkynes. Unsaturated hydrocarbons that contain a C-C triple bond. in alkyne nomenclature, so you have to identify the longest continuous chain containing the triple bond. To find the base name, change the ending of the corresponding alkane from ene to yne or ine. Use a number to designate the position of the triple bond. Number from the end of the chain closest to the triple bond, just like with alkanes. Name substituents like you do with alkanes and alkenes. Now I want you to draw the following alkynes. 4-chloro, 2-pentyne, 3-propyl, 1-hexyne. And now, let's talk about the following formula. We have alkanes, CnH2n plus 2, alkenes, CnH2n, and for alkenes, or that is alkynes, CnH2n minus 2. I want you to remember all of these formula. Now, for nomenclature, I want you to remember the following steps. You have to memorize the prefixes. So we have here the following prefixes, which also indicates the number of atoms present in a structure. Met indicates that there is one atom. Et is 2. Prop is 3. But is 4. Pent is 5. So remember the shape of pentagon? It has 5 sides. So penta or pentagon. Okay? Hex 6. Hep 7. Oct 8. Non is 9. And dec 10. To name, look at the formula for the hydrocarbon. Determine if it is an alkane, alkene, or alkyne. Use the prefix for the number of carbons and add the ending ane or ane, ene, and yne. Ane for alkane, ene for alkene, and yne for alkyne. For an example, we have here, you have to name this compound. For an example, we have here C3H8. And C3H8 is C3H is propane. Okay? It simply indicates that there are 3 carbon present uh, located or presented on this spark. Then we have 8 hydrogen. So these are hydrogens. For multiple bonds, how we're going to name this structure? Now let's try to answer this. How are we going to name this structure? Are we going to start the number on the right side or on the left side? Okay? We will begin the numbering on the right side. Why? Simply because the double bond is located on the nearest end of the right side. Okay? We have 2 double bonds here. This will be carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, and carbon 7. Since there are 7 carbons, this is a hept. And the ending would be ENE simply because this is this structure is an alkene. This is a heptene. Okay? And the double bond starts on the second carbon as well as with the third carbon. Meaning, to name this compound, or meaning, the name of this compound is 2,3-heptadiene. Okay? 2,3, 2, 3, hep. There are 7 carbons. And the prefix di to indicate there are 2 double bonds, and in to indicate that this is an alkene. Okay? Then we have also 2, 4, 6 nona triene. We will begin the counting on the left side. This is carbon 1, carbon 2, carbon 3, 4, 5, 6, 7, 8, and 9. 9 is non or nona. That is nona. Tri, simply because there are 3 triple bonds, and Y and E to indicate that this is an alkene or alkyne. Alkyne. 2, 4, 6 indicates that the triple bond rather, the triple bond begins on the second carbon, fourth carbon, and sixth carbon. So remember this, give first bond or the first point of difference to the lowest number. Include the following prefixes: di, tri, tetra, penta, etc. before the ene or ine to indicate the number of double bond or triple bonds present, and the comma between the number of carbons, the hyphen between the number. The letter rather, the letter. For now let's talk about cyclic structures. Cyclic structures are circular, having cyclo in name, just like the examples that we have here. This is presented in a skeleton structure. And this is now presented in a expanded structure. And this structure is an example. This structure is a cyclopentane. So draw these. So note carbons in double bond should be consecutive, 1 and 2, 5, and 6, etc. So let's try, I want you to, let's try to draw cyclobutene. 1,3-cyclopentadiene and cyclopropane. For cyclobutane, we have this one. this is the structure of cyclobutane. This is now the structure of 1,3-cyclopentadiene. Okay, you may begin the counting here. 1, 2, 3. Or you may also begin it here. 1, 2, and 3. Okay. This could be carbon 1, carbon 1, 2, 3, or 4. Or this could be carbon 1, 2, and 3, 4. Either way. And we have also the cyclopropane. So naming side chains. So names are made up of side chains, the root name. Okay. So this is a 2,3-dimethyl pentane. Okay, how many carbons? 1, 2, 3, 4, 5, 6, and 7. But the main chain or the longest chain is this one. This is now a pentane. And we have two side chains, or sometimes called as substituents. Substituents or alkyl. Okay? These are alkyl. So root is the longest possible CH chain. Must contain multiple bonds if present. And you're going to add YL to get the name of side chain. Okay? Common side names side chains names such as CH3 for methyl, just like this one. This is a methyl. We have CH3, CH2 for ethyl. We have propyl, and we have also isopropyl. Isopropyl can be presented in this matter. And we have also alkyl halides. Alkyl halides, or these are halogens. We have the following halogens. We have Br, or that is bromo, Cl chlorine for chloro, fluorine, or that is fluoro, and iodine, or that is iodo. Naming side chains. So let us try to name the following structure. Okay? So first, you have to take note of to the longest possible chain. Okay? And we will begin the counting based on the bonds here. Okay? So we will begin the counting here. Okay? So we will not begin here or even here. I know some of you might think that the longest chain is this one. 1, 2, 3, 4, 5, 6, 7. But take note, you have to begin the counting if there is a double bond. Okay? You must include the double bond on the longest chain. So this will be carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. Okay? So rule number 1, choose the correct ending. Since double bond, this is a double bond, meaning this is a alkene that ends with E and E. Rule number 2, longest chain, this one. Then next, rule number 3, attach the prefix according to the number of carbon. That is 1 hexene. 1, simply because the double bond begins on the first carbon. Next, rule number 4, assign the numbers to each carbon. Or assign numbers to each carbon. This is carbon 1, 2, 3, 4, 5, and 6. Next, rule number 5, determine the name for side chains. So we have side chains here. We have 3 side chains. This one, and also this one. We have here an ethyl. We have a methyl. And also another methyl. Rule number 6. Attach name of the branches. Okay? So take note that in naming this structure, you have to follow or to arrange it in an alphabetical manner or an alphabetical order. We have 2 ethyl, 4 methyl, 4 methyl, 1 hexene. But take note of rule number 7 and 8. Okay? You're going to list it alphabetically. E comes first before M. And rule 8 and 9, group similar branches. We have 2 similar branches here. Okay? If that is the case, we're going to indicate prefix di to indicate that there are 2 methyl here. And the name of this organic structure is 2-ethyl 4,4 dimethyl 1 hexene. Now let us try to name these following side chains. Now, are we going to name this structure on the top down to the bottom, or we will begin on the bottom to the top? Okay, we will begin it on the top. Okay, this will be carbon 1. We will look now for the longest possible chain. This one. Okay, this is carbon 1, 2, 3, 4, 5, and 6. Then we have also one side chain. This is a methyl attached on the third carbon. And this structure is named as 3-methyl 3, and this structure is named as 3-methyl hexane. Next, this structure may look complicated, but take note of, but you have to look first on the longest possible chain. Okay? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Okay. We will begin the counting this way. Okay? Or you may also do it this way, since this is the longest way or the longest possible chain. Okay? Okay? if we're going to name it this way, there are only 6 carbons. But if we're going to name it on this way, there are 7 carbons, or that is heptane. The longest chain or the parent chain or the main chain is heptane. And now we're going to name the side chains. Okay? We have 3 side chains. The two side chains or dimethyl is located on the second carbon and the third carbon, while the other substituent or side chain here is attached on the fourth carbon, and this is an ethyl. And you're going to arrange it in an alphabetical manner. This is 4-ethyl 2,3-dimethyl heptane. Next, we have 5-ethyl 2,4,6-trimethyl octane. So the longest possible chain is obviously here this, okay, this part. We will begin the naming, or you're going to assign the numbering to the carbon based on the side chains which is located on the nearest end. Okay? So, we have here a methyl which is located on the right side. Okay? It is the nearest and on the right side. This is 1, 2, 3, 4, 5, 6, 7, 8. This is a octane. Trimethyl, since we have 3 methyl attached on carbon 2, carbon 4, and carbon 6. And we have also ethyl on the attached on the 5th carbon. Arrange it according to alphabetical order. We have 5-methyl 2,4,6-trimethyl octane. And always remember that you're going to, in alphabetical order, you're going to ignore this one, trimethyl. Okay? So you're going to base on the structure. Now, let's try to name the structures below. This is a 3-ethyl 2-methyl pentane. Okay, the longest chain, 1, 2, 3, 4, 5, or it could be 1, 2, 3, 4, 5. Okay. Can we start it here? 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. Okay. We will begin it here simply because the methyl is on the nearest end on the left side. And the longest possible chain is 5. Then next, we have side chains attached on the second carbon. This is a methyl. And we have also ethyl attached on the third carbon. And this is 3-ethyl 2-methyl pentane. On this structure, this is a 3-ethyl 1,5,5 trimethyl cyclohexane. We will begin the counting based on the double bond. Okay? This will be carbon 1. Okay? We will not begin it here simply because there is a side chain here. So we will begin it here. The now the the structure here or the point here. This will be carbon 1. Then this will be carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. Okay? For these side chains, we have 1 methyl, 2 methyl, and 3 methyl. Since there are 3 methyl, this will be a trimethyl. Okay? Tri. To indicate that there are 3 methyl attached on this structure. Then we have also a ethyl here attached on the third carbon. And this 2 methyl attached on the fifth carbon. This is a 3-ethyl 1,5,5 trimethyl cyclohexene. Now let us again try to name this structure. Are we going to start it on the left or on the right? Or right to left or left to right? We will begin, for this structure, we will begin the counting where the double bond is nearest to the end or to the nearest end. Okay? So the double bond is our priority now. Okay? We will now assign numbers by locating first the by determining rather first the longest chain. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9, this is a non. Okay? Since it is a double bond, this is a nonene. A nonene. Now, let us determine the location of the substituents or the side chains. The Br is located on the fourth carbon or attached on the fourth carbon. And the methyl is on the seventh carbon. And the name of this structure is 4-bromo 7-methyl 2-nonene. Next, we have here a closed structure or ring structure. Now, for this particular structure, we are going to name the structure based on the double bond. This structure is a 2,5-dibromo 6-chloro 1,3-cycloheptadiene. Okay, we will begin the counting on this part. We will begin the counting on this part. Since this is a ring structure, this is a cyclo. Since there are 7 carbons, this cyclo is composed of 7 carbons, this is a cyclohepta. There are 2 double bond is di, and there are this structure is alkene, diene. Okay, so 1, 2, and 3. 1, 3, 1, 3, 1,3-cycloheptadiene. Now, let us try to locate the side chains or the location of the side chains. So, where do these side chains attach? It is based on the numbering of carbon. Okay? So, we have two bromo at located on the second and the fifth carbon. And we have also one chloro located on the sixth carbon. And the naming, you have to follow it or to arrange it in an alphabetical manner. As you can see, there is there's a need for you to ignore the prefix di. So you're going still to begin it with B. So B comes first before C, or bromo comes first before chloro. You're going to ignore the prefixes such as di, tri, and tetra, and so on. Okay? For this structure, you're going to name it, or you're going to name it left to right, or right to left. You're going to name it on the, or you're going to start it on the right to left. Simply because the double bond is located on the nearest and on the right side. Okay? This will be carbon 1, carbon 2, 3, 4, 5, 6, 7, 8. Again. So again, this is 1, 2, 3, 4, 5, 1. Hi. This is carbon 1, 2, 3, 4, 5, 6, 7, 8. Okay. That is oc. There is a presence of double bonds. This will become a diene. And the fluoro or the halogen or alkyl halides is located here on the fifth carbon, while there are two methyl or dimethyl attached on the seventh carbon. And this is a 5-chloro 7,7 dimethyl 2,4 2,4 octadiene. Again, that is 5-chloro 7,7 dimethyl 2,4 octadiene. Okay? Now, I want you to name this following structure. This is in octane. Now, I want you... Now, let us try to name these following. Okay. And now, let us try to name these following structures. This is a straight continuous chain. It has no branch. All we have to do is to count now the number of carbons. And all of these are single chains, meaning these are all, this is an alkane structure or alkene compound. So 1, 2, 3, 4, 5, 6, 7, and 8. And this is an octane. For the second one, for number 2, as you can see, we have here a 2 side chains or 2-methyl or dimethyl. Okay? So we're going to begin on the left or on the right, or left to right, or right to left. So take note that the side chain is located on the nearest end of the left side. So we're going to begin the counting left to the right. Okay? How many carbons? One, two, three. On the longest chain, 1, 2, 3, 4, 5, 6, 7, and 8. So this will become carbon 1, 2, 3, 4, 5, 6, 7, and 8. This methyl is attached on the second carbon, and the other methyl is attached on the fifth carbon. Okay? And this is a 2,5-dimethyl octane. For the third, or for the third structure, or number 3, we have here a 2,2-dimethyl-3-hexene. Okay, we will begin it where the double bond is near to the end. Okay? And we will begin it right to the left. And we will begin the counting right to the left. There are two methyl located on the second carbon. That is a 2,2-dimethyl. And the double band begins on the third carbon to indicate hexene. Okay? Okay? The longest chain is composed of 6 carbon, hex. And double band indicates that this is an alkene. For number 4, we have a 1,3-diethyl cyclopentane. This is a cyclopentane. Okay? You may start the counting here. 1, 2, 3, 4, 5. Or you may start the counting here. Either way. Okay? This is still a 1,3-cyclodimethyl. 1,3 this is still a 1,3-diethyl cyclopentane. Now I want you to continue naming these following structure. For number 11, I want you to draw the structure of 5-ethyl 2,4,6 trimethyl octane. For number 13, I want you to draw the structure of cyclobutene. 16 to 19, you are going to name these following structures. For number 20, I want you to draw the structure of 3-ethyl 2-methylpentane. For number 21, I want you to give name to this structure.